Thanks. Good morning, everyone. I want to talk about the best programmer I know. The reason I want to talk about this kicked off on the Twitters a few years ago, where someone was saying, that kind of gatekeeping that people do. They're going, you can't really become a proper software engineer unless you have a degree, ideally a degree in programming. So I kind of chirped back, because sometimes I reply to people on the internet. And I replied, I said, well, actually, the best programmer I know doesn't have a degree. And the other best programmer I know does have a degree. He has a first-class honours degree from Imperial College in London, which is one of the kind of great computing universities. So it's not an indicator at all. And then we got into, it depends what you mean by best programmer. And so I kind of did a stream of consciousness thread thing on the internet about what I thought made this particular person a great programmer. And then I did nothing, because I'm really bad at following up on things. So I've finally now sort of turned it into this. And okay, so the best programmer I know happens to be male. That doesn't matter, right? Because it's not about him, okay? The things I'm going to talk about this morning I've seen in many, many different programmers. I've been computeringing for about 30-something years now. So I've worked with lots of really lovely programmers. The most important person to think about when I'm describing my buddy is you, okay? Because everything I'm going to talk about this morning, everything is learnable. Everything is behaviors, is choices you can make. So my challenge is this. If you're new to this, if you're relatively new to this whole computering thing, here are maybe some things that you might find useful, you might want to move towards. For those of you who've been around for a while, some of this might challenge you. Some of this might kind of, wait a minute, I don't agree with that thing. And I'm very, very happy for you not to agree with this, right? There is no absolute truth in this. These are my opinions. If you don't like them, I have others, okay? So let's start. This is a talk in 3 parts. It's deliberately a talk in 3 parts because I want to get a lot of stuff across to you. And if I don't arrange it into chunks, it's just a big laundry list of things, okay? So let's start then. The first thing this person does is he gets the job done, which sounds really obvious, right? But we're not very good at getting the job done. So how does he get the job done? He just starts. I have a real problem with just starting. I have always struggled with just starting, okay? So what I do is I procrastinate. I don't call it procrastinating. I call it research. I call it looking up things. I call it preparing myself. It's procrastinating. I'm 12 years into writing a book. 12 years. I'm embarrassed by that. You should all be going, oh my God, how could it possibly take anyone 12 years? It's easy. Just month after month after month, don't write any more book. And eventually, 12 years in, you haven't written your book, right? So what does he do? He just starts. He has the ability to just start. And the reason I struggle with just starting is I have a massive ego, right? Partly because I'm human and partly because I'm a programmer, okay? We've got big egos. And what that means is when I put code into a computer, I want it to be good code. I'm proud. I call it perfectionism. Perfectionism isn't about wanting to build a perfect thing. It's about having a very fragile ego and not wanting to get wounded. That's what perfection, I know because I'm a perfectionist, right? So what he does, which I just find brilliant, and again, I've spent the last probably 15 or so of my 30-odd years in my career trying to explain to people how this person does stuff. Right? I've made a career out of it. He gets really embarrassed. I'm not going to tell you who he is. He finds this amusing that I do this, right? But what he does is this. He goes, I'm just going to start, it's because I know whatever I write now won't be there in 10 minutes. Because what I'm writing right now is a sketch, and I'm going to iterate on that sketch. So what he then does is he just iterates wildly. There is a Smith reference in there for some of you more nerdy 80s fans. Iterate wildly. And so there's this idea, in the US, they have a lot of gridded cities. So the cities are kind of laid out like a grid. And in the morning and in the evening, they set up all the lights so that all of the, what they call downtown traffic going into the city has all the green lights, and in the evening, all the cars coming out of the city get the green lights, which means if you're going cross town, then you're going stoplight, 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 okay? It's pretty frustrating to go across town in US cities, in Chicago or New York or somewhere like that. So here's what you can do. You can either sit there in your car, wait for all the lights to go green, because then you can go, or you just go stoplight, 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 which is really dull, but you're making progress. And eventually you get the other side of town. Which one of those is going to get you there? Right? And this is the thing. Rather than waiting until I've learnt Node.js, learnt React, learnt Rust, learnt CQRS, the thing, whatever it is I'm going to try and do, I just iterate through it. And I iterate knowing I'm going to mess it up, and knowing that every time I mess it up, I learned a tiny thing. Okay? So I come out of it the other side, the person who knows the thing now. But I've got no idea what that journey was going to look like until I took it. So just start. The next thing he does, which I really struggled with for a while, I think I'm better at this now, right? But I only think so, because I keep catching myself. What he does is he builds a product. We are building a software product, okay? Which sounds really obvious, right? But the whole software craftsmanship movement came out of like the opposite of this. Right? I am going to build fantastic code. I have the right to build amazing, great code. I don't care. I mean, write good code, right? Take it seriously, but I don't want your code. I want what your code does. In fact, if you can give me what your code does with no code, you win at code. That's how much code I want. I want no code. If I can get the thing with no code, we're winning, right? So code is just a means then. But now you have this, and I describe this as you're holding two conflicting ideas in your head at the same time, which have been reliably informed by a psychotherapist friend of mine, is impossible. Okay, it's impossible to hold two competing ideas. These are the two competing ideas. I will write the best code I can, or at least I'll write the most suitable code for this situation. I'll write the best code I can for this situation. I will have no emotional investment in my code. I'm going to struggle with that second one. Have you seen this? I had a moment. I've just written, and I know if you've been around code for a bit, you've had that moment where you've had this puzzle and you've solved the puzzle and it is elegant. It's just lovely. You've written a lovely bit of code. And you stand back and you go, don't care whatever else happens today, that's a lovely bit of code. Okay? So I showed my buddy. I said, come and look at that. That's a lovely bit of code. Am I right? That's a lovely bit of code. And he looked at it, he went, is it live yet? Is it live yet? I hate you. So how do you resolve this conflict? How do you resolve this not having an emotional attachment to something you're taking seriously? And it turned, I realized after a while of observing us and in this very high-performing team, is this: we were caring about the product. It happened to be a trading system, a trading platform. And the point about a trading platform, traders do not want to use trading software. Traders want to trade. That's what they want to do. Ask traders. What do you want to do? I want to trade. Why do you want to trade? Because I make money. The act of trading is the shortest possible value stream between do a thing, make money. But you're buying and selling money. It's very weird. So what they don't want is your product. What they don't want is the software. The software gets in the way. And we've had some wonderful talks about like developer experience and user experience over the last couple of days. And it's thinking about a product as something that should just be invisible. It should be fabric. You shouldn't be aware of it. So how do we do that? Well, what we do is we study the domain. We learn about what it is the software is trying to do. Yeah? So if I understand how trading works, I understand how healthcare works, how patient record management works, if I understand how supply chain works, if I understand the pieces, I can start to think differently about how I solve puzzles in that space. Okay? And then we get into I know we were talking yesterday about like the kind of the interplay of things like Wardley maps and domain-driven design and bounded context and all of this kind of stuff. We can only start to do that thinking. We can only start to have those conversations when we study the domain. Okay? And by the domain, I don't mean abstract the world of trading. I mean the people who live there, right? What do traders do? What do trading assistants do? What does compliance do? In a hospital, it's not just doctors and nurses. There's huge teams of people that enable medical care to work at any kind of scale. And this is what your code looks like. Your code has the words in it from the domain. Okay? And watch people. There's a lovely word, ethnography. Ethnography is a fancy word for watch people. Okay? The most powerful bit of user feedback you can get, everyone, please, all of you, spend some time with your users if you possibly can. Sit next to them, watch them using your stuff, and you're listening for this. Yeah. What was that? You just sighed. No, I didn't. People don't notice when they sigh, right? You did, you sighed. I know why I sighed. Well, why did you sigh? Well, because basically whenever I do this, right, this thing comes up on this screen, and I have to just type it in again into this screen, and sometimes I get it wrong, I get the surname, I misspell it slightly, or there's a hyphen that goes away, and you're like, why are you doing that? I don't know, just the software, it kind of comes up on this screen, I've got to put it on. I could make that text just appear on that screen. I could have this form populated for you, and the eyes go wide, and they're like, can you? I'm a programmer, I can make a computer do anything. Watch me. Right? But they're never going to ask for that thing. They've got a feature list as long as your arm, and none of it is, I have to keep copying from that screen into that screen. Because they've already internalized that this will never change. This is the way things are. Right? So Bill Buxton, Chief UX chap at Microsoft, he has this lovely, he asks the question, he goes, what is user experience? And then people talk about design and affordances and interaction. He goes, no. User experience is the experience a user has. Oh, yeah. So user experience could be frustration, could be silent resentment. It could be pleasant surprise, right? Whatever that emotional response is to the thing, you caused that. Your software made that happen. You can be writing software. Even internal business apps are notoriously bad for this. Right? I need to get the work done, not one of my colleagues who I share a canteen with at work is having a miserable, crappy day because of a thing I built. And they're going to continue to have a miserable, crappy day because I know what the next screen does too. And imagine it were me, what could I do to make it just joyful? And have people come up to you and go, look, I know it's only an internal system, and I know you've only got these 6 users, but thank you for thinking of us. Because when we get to use this part of the workflow, it's the only time of the day we don't hate our jobs, right? So think about your human beings in your world. I really struggle with this. Solve for now. Solve for now. Do not pan back and solve for the abstract case. I had a massive argument once with a chap called Eric Mayer, who's also Dutch. Eric Mayer has possibly the biggest brain of anybody I know. He's one of the people, he wrote Haskell. He doesn't write in Haskell, he wrote Haskell, right? Link, L-I-N-Q, the query language in .NET, that's him. He's done a bunch of really crazy things. And we got this, we were at some workshop thing, and I got into, don't get into an argument with Eric Mayer, that's what I learned there, right? But we were coming at this thing from very opposite ends. I was saying, well, always solve for now, and then once you've got enough samples, then you can think about generalizing and think about a library or an API. And he's like, no, I'm not going to try and do a Dutch accent in a room full of Dutch people. That's crazy. He says, no. He says, that's maths, science. Start with a general case, apply it in individual. And we got into this big Barney, and luckily we had someone there who's a mutual friend who kind of helped us see eye to eye. The difference is this. I write business software. I write applications. If I get something wrong, the distance between me being wrong and the thing being fixed is the next release. It could be a week, it could be days, it could even be hours. Eric designs programming languages. If Eric gets something wrong in a programming language, the arc before that thing gets changed can be, there's stuff in Java that is @deprecated, that has been @deprecated for longer than most people in this room have been programming. It will never leave the language, right? So, and we came up with this idea, we call it a change event horizon. So my change event horizon is days or weeks. His change event horizon is generations. So guess what? He has to think about the general cases a little more than me. But when I say solve for now, Terry Pratchett has this wonderful, says all series of fantasy books. And there's these, one sort of little mini arc within this series is about these 3 witches. And one of the witches is called Granny Weatherwax. And Granny Weatherwax has, and Terry Pratchett says he has first sight. Because I always think of like witches having second sight and being able to, commune with blah. He says she has first sight. She can see what's really there, right? My buddy, he has first sight. This is not a pipe. This is not even a picture of a pipe. This is some black dots that are in a shape that is suggestive to you of a piece of abstract art. So I'm making a reference to a reference. No, it's not a pipe, okay? It's just some lines on the screen. So I'll give you an example. One day he said, I'm going to write a Java web server. Like, there are literally hundreds, or certainly many tens of Java web servers. They've been around for decades. And he says, no. There are no Java web servers. I'm like, we've got Tomcat, Glassfish, Jetty. He goes, yeah, all of those are servlet containers. A servlet container, back from the mists of time, like the late 90s, so Sun and then Oracle came out with this really, really complicated thing called Enterprise Java, and in that was a thing called a servlet, and a servlet had a life cycle. And the servlet life cycle methods were maybe 10 or 15 different methods that you had to interact with in different callbacks. So your table stakes for a servlet container was this big complicated thing. He didn't want that. He wanted a web server. So he sat on the train. He used to do a lot of coding on his commute. Sat on the train, HTTP 1.1 spec, right? Public static void main. Yeah? Wrote a event-driven Java web server, which was insanely performant. I mean, it was nuts, because all it did was serve HTTP, which is what he wanted, right? So think about, when you're looking at a problem, think about the problem you're really solving rather than the one that presents itself. Because I like to think I'm good at this. I've been doing this for a long time now, and I see a problem, and I'm like, oh man, I've seen this problem before, I know what to do. And I'm about to go do it, and he comes up and he goes, wait, isn't it just that? And you go, I hate you. I've done it again. And it is just that. I was seeing this thing. It turns out that is actually the problem. And he writes a bit of code, and that goes away, and all of this crumbles away as well. And then he goes home. And you're just left there with, what did I just witness, right? And this happens again and again and again. And so you solve the real problem, okay? We always want to solve a generalized. So I was with one client once, one team, and there was a big argument going on. I walked into the middle of this big argument. And what's the big argument about? We're trying to choose which JSON library we're going to use. So okay then, because it's again another Java shop, lots of JSON choices. So I said, okay, so let's talk. And then there's these folks that basically bedded in, right? We're going to use this one. No, we're going to use this one. And there was this like standoff. So I said, okay, right, let's think about this. How many actual things are we going to JSONify? How many things get sent across the wire? Big code base, really complex thing, about 9. About 9 things. I was like, okay, so what if we just had an interface called JSONify, and it had toJSON as a method that returns a string? Because that's what toJSON does. Right? And they said, but what if we change the class? And I said, well, then you change the toJSON method. It's like, oh, right? And you look at any of these libraries, particularly Java or JavaScript, the node world. Pick any tiny library, and it brings in this slew of dependencies. Yeah, and now suddenly you have all of that security attack surface area. Right? You have all of that dependency, all of that weight, all of those out of date or vanished, that should have left pad scenarios. So just think about what you're trying to solve and just solve for that. And again, I've done a 180 on this. I used to be very much kind of like, if there's a library, go do it, go get it. Yeah. Now I'm much more like, if you're going to end up in my code base, if you're going to end up in my build, you really need to earn your space there. Okay. And again, strive for simplicity. Right? There's a lovely Oliver Wendell Holmes quote. He said, I wouldn't give a fig for the simplicity this side of complexity, but for the simplicity the other side of complexity, I would give anything. Yeah. Once I've understood the problem and I realize it's just this thing, so okay, part 2, choosing the right tool. This is another thing I've done a full 180 on. Okay, this is quite a confessional talk, quite a mea culpa talk. I'm about to tell you something that I used to, and I don't hear this very often. Choose the right tool for the product, for the situation, for the problem, not for the team. I have been in many, many teams over the years where we're about to take on a new thing, and the choice is, well, what does the team know? Let's start with what the team knows, right? We're a Java team, we're a .NET team. And then you get the C# versus F# nerd stuff. And you go, okay, we're a React team, or whatever it is. And this is the thing. This is, again, a rethink in terms of your identity. If you identify as a Python programmer, you're kind of stuck. If you identify as a programmer who's using Python, who knows Python quite well, suddenly you can be a programmer who knows some other things too. It kind of unlocks you, right? And because people are smart. People can learn stuff, yeah? So, code outlives teams, data outlives codes, data outlives organizations, right? I've seen databases, I've seen data backups from organizations that have been ceased trading 20, 30 years ago. You want to see, especially in big banks, because the way you get big banks is you squish together lots of smaller banks, okay? And I was working at Bank of America, which is the biggest bank. That's the end of the sentence, right? Because there has to be a biggest bank, and it's them. Or sometimes it's HSBC, depends how you're counting. But basically, the way you become Bank of America, Merrill Lynch, the clue's in the name, is you squish together all these legacy systems, and so on. So code outlives teams. The situation, choose the code that fits the situation, and the team will evolve around that. So again, we had a situation where we wanted to build another trading story, a trading stack from scratch in a very, very short amount of time. Very briefly, to do electronic trading, you connect to an exchange, which all have their own weird API and typically weird binary protocols, so you need to do that. Then you need to get what's called market data, which is what everyone else is buying and selling right now. So that's like a fire hose of messages. There might be hundreds or thousands of those per second coming through. You've then got to have what's called your algorithm, which is the thing that decides what you're going to buy or sell or cancel or whatever else. You then have a really, really complicated thing called order management. Order management is very easy to describe and really hard to get right. All you can do with an order is buy a thing, sell a thing, or cancel. That's it. Buy 10 Apple, sell 10 Apple, or change it to 8 Apple, cancel. So let's do that. I'm going to go buy 10 Apple. Oh, I've changed my mind. Adjust it, make it 8. Actually, cancel the order. I don't want to do this. And off go those 3 messages, but they arrive out of sequence because computers. Okay? So the first thing that arrives is the cancel. Cancel the order. What order? Don't know. Right? And then amend. I don't know what you're talking about. Buy 10 Apple. Okay. So now I've got a live order on an exchange that I think I don't have anymore. Okay? Now imagine thousands of those happening concurrently. It's a very complicated world to keep track of. So we're going to build that. We're going to build it from scratch, and we're going to use Scala. Why? Because, says my buddy, no one knows Scala in the team, but I reckon I can sketch in Scala faster than we can sketch in Java. Kotlin didn't exist then, otherwise it would have been Kotlin. But we said, well, let's just use, you can basically write scripts in Scala. So we just started hacking away in Scala, and they learned Scala doing this. I joined the team when they were version 1 of this, and I just saw some of the worst Scala I've ever seen. I'm not a great Scala programmer, but these folks were just dreadful, right? And so these dreadful Scala programmers had written this dreadful trading system in a small number of weeks. Now, this is the thing that would normally take a larger team several months. But they'd thrown this thing together, and this rubbish code in rubbish style, in a rubbish language, was making a ton of money. How can it possibly be making? It's held together with gaffer tape, right? But it didn't matter, yeah? All of the stuff that it had to do, the legal stuff was all in place. So it was allowed to trade, and it was making money. And so gradually, bit by bit, we iterated on it, and we made it make more money a bit more safely. And eventually, I think there wasn't any Scala left after a while. So we do the simplest thing, okay? Not the easiest thing. A lovely hat tip to Rich Hickey. If you haven't seen this Simple Made Easy talk of his, Utterly, utterly brilliant. I've given you a short, and I've got my own URL shortener on my website. Pro tip, if you give talks, have a little redirector on your website. So dannorth.net/go/simple-made-easy. Brilliant, brilliant talk. And he's talking about, well, he also introduces a completely unnecessary word, which kind of defeats the purpose. But he's saying that the easy is the stuff that comes to mind. I know yesterday we were hearing about Daniel Kahneman and System 1 and System 2. So your System 1, your kind of instinct, is that's the stuff that pops into your head. It's not the right stuff, it's the stuff that was closest to the front to top of mind. And we have this cognitive bias that we believe that that's right. We believe that things that are easy to think of are the right things, and often they're not. Often we need to think past, let the easy stuff go, and then think into the problem and go, what would be a more suitable way to, oh yeah, we could do that. It's going to be harder, but it's the right thing to do. I need to learn my way into how we're going to do this properly. Okay, and bear in mind, stuff changes. Technologies change. The problem changes. The customer changes. The domain changes. Okay, the needs change. Scale changes. Legal frameworks change. The context you're operating in changes. Okay, so what was the right tool back then might no longer be the right tool. And it's okay. It's okay to change that. It's okay to say, yesterday we were wrong. So revisit your choices. Kent Beck has this lovely phrase, make the change easy, then make the easy change. So when we're refactoring, I want to introduce a new thing. Oh, it's going to be tricky to introduce a new thing. Why don't I change the code so that my change is going to be easy, and then I'm done? Okay, so I just want to unpack this make the change easy thing. I find this a really, really powerful back pocket kind of maxim, if you like. I'm working with a team and they're like, oh, we've got to do this thing. And I go, make the change easy. And I sound really wise, okay? Using someone else's thing. Why don't you make the change easy? Oh, you are so wise. How will we do that? I don't know, but it sounded really good, right? So we can make the change easy by building software where it's more likely that the change is going to be easy, whatever the change might be. Okay? So this idea of blast radius. So when I'm making a change, if I write small self-contained pieces, they don't have to be microservices. Microservices is one implementation of a broader pattern that I call replaceable component architecture. So replaceable component architecture is this idea of having small pieces with what they call a hard shell and a soft center. So the hard shell is a clear API, clear message passing, whatever it might be. Inside that, you can do what you like, as long as you respect the shell. And then you have these little hacks. Everything's a hack. And there's a pattern I've been talking about in my yet unpublished book, Spike and Stabilize. So Spike and Stabilize says this. It says treat all code as a spike. Everything you're doing is a spike. Because every line of code you write is speculative. I think we're going to need this, right? I think we're going to need this. I might have more or less confidence that I think we're going to need this, but it's not until the rubber hits the road, so we've just had a Formula 1 talk, that we know, right? So if we treat all code like a spike, but we kind of respect that it's still going to be production code. So we make a good spike, but we don't overinvest in it. And then what happens is over time, we notice the code that works, or the code that lasts, the code that we're still using. And that code we invest in. And it's a lot like firing an arrow and then drawing targets around it, right? You get a lot of bullseyes. It's really cool. So we're going to invest, we're going to write tests for that code. So try now, pay later. The code ends up looking test-driven, but you don't overinvest in it. And then reduce, reuse, recycle. This idea of iterating on code. So I want code that's easy to decompose. If it starts getting a bit big, I break it into small pieces, okay? If I want it to do something different, it's easy to do something different. And if I come up with a better way of doing it, remember that emotional attachment thing? I'll just delete it. I'll write it again in something else. We had bunches of Scala that we rewrote in Python because it was the right technology to use. It made it easier to reason about. So my buddy does have a bit of a reputation. Some folks have picked up code that he's written and they've gone like, this is a complete mess, I don't know what to do with this. And the reason they have the problem, my theory, the reason they have the problem is they don't think like he thinks, right? They're thinking, and I need to look after this, I need to maintain this code. Not, and if I can think of a better way to do it, I can delete it and no one will care. Right? Least of all the person who wrote it. They'll be delighted that you came up with a better way to do this, okay? And here's the secret. Don't tell anyone, right? We're not recording this, are we? Do that with your production code. Do that with all your code. All your code is a spike. All your code gets stabilized, okay? Cupid, acronym I made up a couple of years ago, about characteristics of software that brings you joy, that makes you smile when you crack open a code base. Things are composable, things are Unix-like, they do one thing. Things are predictable. So whether or not you have automated tests, that's one type of predictability, but then the kind of the charity major sort of observability type of predictability as well. And then idiomatic, so if you come to a technology, people have written code in the way that other people would write code in that technology. And you go, oh, that's nice. This looks like, this looks Pythonic. This doesn't look like someone's trying to write Java in Python. And then think about architecture isn't this series of baked-in decisions that you made. It's a series of options, a series of choices you make. And for every architectural choice you make, think about what's the cost of reversal. What's the cost of making that a different choice? And try and make architectural choices that create options in this way. And be a polyglot. When I say be a polyglot, learn lots of different things. If you learn lots of different tools and technologies and languages, they change how you think. So Eli yesterday was talking about as we learn language, as we learn culture, it changes the thoughts we're allowed to have, we're able to have. So I'm a huge fan. Who does Advent of Code here? Yes, lots of hands going up. Advent of Code, this crazy German guy, Eric Wessel, every year he creates a 25-day, it's called Advent of Code, and on each day there's a 2-part puzzle, and it unwraps at a certain time, Eastern time, and there's like speed coders. I'm not a speed coder. What I do is I use Advent of Code to learn a new thing. So the idea is that part 1 of the puzzle is usually a fairly easy question or something you can Google an algorithm, and it always involves Dijkstra. And then you code that up. And then part 2 is cleverly structured to break your answer to part 1. So say it's a game of life thing and you have to code up game of life for part 1. Part 2 is game of life on a vast, huge, sparse array. So you can't use the thing you used. You now have to think of a different data structure to store game of life in a vast array. That kind of stuff. He messes with you. Or the input to part 1 is like 10 lines and the input to part 2 is 20 million lines. That kind of thing. So what I've done is I learned Rust using Advent of Code. One year I started doing it in Kotlin, did the first 10 days or so in Kotlin. Then I went back and did a few days in Go, because I don't like myself. And I wanted to, so what I wanted to do, I had this hypothesis, because Go is a pretty clunky language. Basically, it only has for loops, right? The way you do anything in Go is for, right? And so I was pretty confident that whatever solution I came up with in Go would be much bigger than the solution in nice, neat, clean Kotlin. Turns out I was completely wrong. They're about the same size. They're different code, and you approach it differently, and you're still frustrated that you don't have these lovely functional affordances like your maps and reduces and those kind of things that you have in Kotlin, but you can get work done. And it takes about as long. And I was like, oh, interesting. So go learn a thing. Be full stack, air quotes, be full stack. If you're a back-end developer, which doesn't mean you're a back-end developer, it means you're a developer currently working on back-end systems, right? See what I did there? If you're a back-end developer, think about what makes a great web page. Think about websites that you use, web applications that you use that you think are awesome, and what makes them awesome, and how could you do that? Right? You don't need to do it as well as the people who built it, but if you do it well enough to get by, you suddenly became a superhero. You can make a computer do anything. Likewise, if you're a web developer, understand SQL, understand how databases work, because they're really cool. There's a reason they're still going after 50 years. They're an amazing technology. And when I say full stack, be really full stack. So one thing that this buddy of mine does, he's not afraid of hardware. Right? I'm terrified of hardware. Yeah? He's not afraid of hardware. We had one situation, the team was quite scattered around a building, and we used to have a stand-up, and people would drift in and out of the stand-up, and everyone was late and whatever. And sometimes people got stuck coming into work. So he took a, that was easy button, the Office Depot that was easy buttons, and he wired it up so that when you hit the that was easy button, it sent an SMS to everyone saying stand-up time. Right? It took him a morning. Yeah, but he had to go and learn about SMS gateways and how you get signals out of things and all that kind of stuff. Built. So the first person to stand up would just hit the that was easy button. 5 minutes later, everyone's there. Right? So be really full stack. And sometimes, why even solve the problem? You know, we're all sitting there stroking our metaphorical beards about how we're going to solve this problem, and he rocks up and says, why are we doing this? You know, what do you mean, why? Well, look, if we did this other thing instead, doesn't that whole problem go away? I mean, technically, yeah. So think it through. The last thing I want to talk about is really important. We do a lot of talking and learning and listening and thinking about technical stuff. Okay, and technical stuff is important. Being good at technical stuff is important. Being good at people is also important. I hear the term hard skills and soft skills, and I am not a fan of that language. The reason I'm not a fan of that language is this. People skills are hard skills. They're hard skills because they're learnable, they're testable, they're measurable, they're transferable in exactly the same way any other skill is. Okay, and I talk about people skills in my world. There's leadership skills, there's collaboration, team skills, and there's coaching and mentoring skills. And all three of those, all three kind of dimensions of those are learnable, are transferable, are hard skills. They're hard skills that involve people. There are no soft skills in this, okay? Let's think about caring about the team. Well, the first thing is about caring about others, okay? I'm looking around the room. There's a few people here who probably are no longer in their 30s. They've left their 30s behind. Some of them left their 40s behind. You know, some of you are looking after teams. Some of you are looking after teams of teams, okay? One of the things that my buddy does, and I do, I've just done this my whole working life, is find joy in helping others. It's not about just, oh, I've got to onboard the new person. I've got to get this person moving. Actually, if you find joy in that, so I love the thing where you're sitting with someone and their eyes just, they get it. And they go, wait, I can do it. And you go, yes. Yeah, and you get to celebrate that moment with them. Teaching is the best way to learn. Putting on a talk, putting this talk together. I learned loads of stuff researching this talk. Okay, so those of you who are nervous about talks, about standing up on a stage like this, go do talks at work. Go do talks in your team. Go do talks in your company. Go do talks at meetups. Go just share that knowledge. And sometimes you can't help. Sometimes you don't know the answers, sometimes, but you can still be encouraging. You can still say, you got this. I believe in you, right? Send the team home. This is really important. When people go, oh yeah, you know, we work like 70 hours a week. I'm like, that's not macho, that's not useful, that's poor management, right? That means you don't know how to get the work done in the time you've allowed for the work. So either you've taken on too much, so you need to start learning to say no. The things you're doing are not the right things, so you need to learn to do better things, or you're just not very good at them, in which case you need to practice. Right? One of those three things is true. Go home on time. Okay? No one should be working late. If your team is rested, they're going to do better work. What I love about the world at the moment, the technology world at the moment, is we're hearing more and more about people talking about their families. I can't make that Zoom call because I'm doing the school run. Right? I love that. I love that a lot of organizations are becoming more empathic, right, and more aware of these things. And this isn't being fluffy and cuddly and whatever. This is just good, solid economics. I will get more out of a team that is rested than I will out of a team that is burnt out. Fact. Okay? And be kind. Be kind. Assume everyone's doing their best. Yeah? As I say, I've been doing this for 30-something years now. In all of that time, I've met two people who simply shouldn't have been there. They were just in the wrong job. They should have been goat farming or something else, right? 2. For everyone else I've ever met who's struggling, and this again, when you're managing a team, you're not managing people, okay? As a manager, you're not managing people. You're managing a system of work that has people in it. That's different, right? You're managing a system of work that has people in it. So if someone's struggling, it's not like, we need to talk because you're clearly struggling, right? It's, I've created a system in which this person is struggling. I've created a system that presents as it's really hard for them to get work done. That's on me, right? I'm shouting at the plant for failing to grow rather than looking at the soil and the light and the water, right? Let's just shout at the plant a bit. All the cars are stuck in a traffic jam, yeah? And I'm shouting at one individual car for not moving. It's not the car's fault. And there is also nothing that the car can do about it. All the cars around it, yeah? They're all stuck in the same system. So let's think about the fact that we're in a system, and let's be kind. Psychological safety is one of these things that has sadly become subject to semantic diffusion. Everyone thinks they know what it means. Not enough people knows what it means. Professor Amy Edmondson came up with this term. It is just brilliant. She wrote a wonderful, wonderful book called The Fearless Organization. And fearless organizations are, psychological safety happens at a team scale. It's a team construct. You don't have psychologically safe organizations. That's not a thing. It's a team construct, and it's a choice within a team. And it's what's called interpersonal vulnerability. Whether I'm okay sharing with you that I'm a bit stuck right now. And it boils down to three things, and they're all learnable. The three things are this. When someone says, I need help, right? In a psychologically safe team, I need help is about collaboration. Okay? In an unsafe team, it's you are incompetent. If you need help, you're incompetent. Yeah? I have a question. I have a question in a psychologically safe team is I want to learn. I need information. In an unsafe team, I have a question is ignorance. Well, clearly you don't know the stuff, right? You need to go learn the stuff. And the third one is I disagree. So I disagree is either you're trying to improve things or you're a troublemaker. Right? So think about how your team responds to those three questions, and that gives you a lot of clues about psychological safety. The next thing about caring is about you staying current. Okay? It's all well and good being great at your thing, but as I said, things are changing, things are moving. Okay? Care about staying current. Plug into communities. Plug into different networks. Be a net contributor. Be the person who says, oh, I can help with that thing, right? Or I had that experience, yeah? And plug into communities that aren't like you. Try and get out of their echo chamber. I mean, don't plug into communities of toxic, evil, horrible people, because that's just silly, right? But plug into other communities that are going to challenge how you think. And respectfully shut up and listen. One great bit of advice I was given is this: if you're right, you'll still be right in 5 minutes. Okay? So shut up, wait 5 minutes, and see if it's now's the right time to talk. And try new things. Try new things, always be trying new things. Don't get stuck in the kind of shiny object, hamster wheel thing. Retain a healthy skepticism, right? Since I wrote this, no, blockchain isn't cool anymore, AI. Spoiler, artificial intelligence is not intelligent. There is no intelligence. Artificial intelligence is in LLMs, certainly large language models, is really, really good stats. Okay, it's really, really good high school. All that high school stats that you ignored, you can make a living in now. Okay, it's very, very lucrative. So, be skeptical. Explore these things, learn about them so you can have an opinion about them. And practice. I think probably one of the most important things I want to say, there is no innate programming gift. Okay, that's not a thing. Programmers are not born, yeah? Programmers, they're really great, and I've been very lucky. I've worked with some astonishing programmers over the years, work really bloody hard at it. They practice and practice and practice, and it's that humble practicing. It's that humble practicing of I'm going to try this thing knowing I'll be rubbish, right? Go in there knowing you're going to be rubbish and knowing that that's only going to be a stage you went through. Right? Any of you who are parents, right? When your little one started walking, you didn't go, wow, that's rubbish walking. You're dreadful at that. You should just stop, honestly. The crawling thing, you basically had, what? That's not walking, you fell over, you idiot. Right? No, we don't do that, do we? At least I hope we don't. Right? But you go, yes, you made 3 steps before you face planted. That's brilliant. Right? We're encouraging. We build each other up. That's have that mindset, yeah? And care about yourselves. You've got this. You've got this. I believe in you. Okay? This stuff's hard. Yeah? Computing is hard. Living in the modern world is hard. Right? Trying not to destroy the planet we're on is hard. Yeah? So take yourself out of that bubble sometimes. Have interests outside of programming. This chap I'm talking about, he's done acrobatics, like circus acrobatics. He learned how to do flips and tumbles and that kind of stuff. He's a dad. He's very family-oriented. Find a sport or an activity that you do. I used to do jiu-jitsu 100 years ago. I loved it, really enjoyed it. I discovered I like running. In my 40s, I discovered I like running. I never liked running. I always thought running was pointless. And then I tried it. I was like, this is really nice. I like running. Cycling. I love cycling. Find a sport. If you don't have a sport or an activity, try loads of activities and find the ones that you like. And go, wow, I had no idea. I had no idea that Lego could be that cool. Here I am building massive things out of Lego. It's very cathartic. It's very therapeutic, right? You know that thing about sending your team home? The best way to send your team home on time is to model that behavior. It doesn't matter what you say to people. They will do what you do. They won't do what you say. So if you're always the first one in and you're always the last one out and you're telling everyone to go home, you're going to find that they don't listen. Yeah? So when you say, I'm going to go and spend time with my family now, you should do that too, right? It sends a very strong message. I heard one of these kind of pithy quote things recently, and it really landed for me. They said, who's going to remember you working late at the office? And the answer is not the people at the office. They're not going to be the ones that remember you not being around. Yeah? No one at the office will remember you working late at the office. And honestly, sleep is the best debugger. So many times, I've been noodling on something for hours at work, gone home, next morning going, oh, you idiot. Right? My buddy actually, he had a dream one night where his then girlfriend, now wife, told him the answer to a thing. And she was right. Which is pretty cool. So, it's this unconscious going, well, have you tried this thing yet? And he's like, oh, no, but when she told me, it made perfect sense. And be kind to yourselves, One of my favorite blogs, a chap called Dan Bodart, I don't know if he's still blogging now, but the strapline on his blog was, yesterday I was wrong, which is just such a lovely, yesterday I was wrong. I'm writing this stuff, of course I'm writing stuff that I think is right, but yesterday, as soon as I posted it, I'll look at it and I'll go, oh no, I don't think that anymore. I've learned since then, yesterday I was wrong. So give yourself the space to go, do you know what? I'm probably going to be wrong today, and it's probably going to be okay, because we'll be fine, right? I've got a good team, got a good support network, I'm taking care of my physical and mental and emotional health, right? I've got this, I can do this. So that's kind of really what I wanted to talk about. So get the job done. We're here to build products for people to create impact in some way. That's the job. The job is not writing software. The job is not coming up with really clever architectures. The job is getting the job done. And we get the job done by choosing the right tool. Okay? And we choose the right tool for the situation, for the product, not the easiest tool, not the one we happen to know. Otherwise, everything looks like a hammer hitting a tiny little walnut. Yeah? And care about the team, care about yourself, care about your own growth, care about your own development, care about staying current. So yeah, if there's one thing you take away, above all, be kind. Thank you.